Okay, so in this video I wanted to give some information as to the type of bearing that we are using, bearing or bush, whichever you prefer to call it, on the Printtable S Series. Now the original Printtable that we built was using the LM8UU type bearings, which essentially the 8 stands for the 8mm diameter internally, because we used 8mm rods. Now, we use these bearings. Traditionally, these are the type of bearings that you find on most 3D printers. They're the ones which are widely available, and therefore, as a mass-produced product, they're copied and are very cheap to purchase and available from virtually anywhere in the world. Most of these you'll find are imported from China, and that's where they tend to be mostly mass-produced. However, what I found is inconsistent quality with this bearing. I would insert some in, I would find the little ball bearings coming out of them. I would find some sloppy, I would find other ones tight. This one in particular, it's a brand new bearing, and yet it's quite tight running up and down on that. I've got no free movement whatsoever. And then we've got the noise it actually makes. It's like a grinding noise of it grinding up and down on the rod, which in turn, it may settle in over time, but it does make the printer a bit more noisier. So I decided to start looking at the bushes and the bearings and start using alternatives. So the one that most people then opted for is a solid Igus Drylin bearing, and this particular model on this one is RJ4JP0108, and the 08 again meaning the 8mm diameter. Now, whilst this bearing does operate a lot more smoothly and in size and dimensions is a direct replacement for the LM8UU type bearing, what I found with these was just a little bit too much play in the bearing itself. So as I was having these on the Printtable and trying them out, I just felt that movement was something I needed to improve upon. Was I had the smoothness and I had no sound. So I went back to market and started looking at alternatives and found that Igus did this new type bearing, which is an RJM0108. Now with this type bearing, it's not the same dimensions as the LM. I'll put that actually. Let's try and show you. So we've not got exactly the same dimensions. This one is slightly bigger than this one, so any of the printed parts needed to be redesigned in order to fit this bearing into place. But what I did find is I got that smooth action. I've just got a little bit of grease on there, and this is the thing, these bearings don't want grease at all. They're designed to run completely dry, so any form of grease will actually form a little bit of resistance. So you can see there I've got a lot smoother action and very little sound as it travels up and down the rod. What I also found is the tolerance of this bearing against the 8mm was far superior, so very little rock movement in that bearing. But even if there was, I had the added advantage that these are designed to be a slight interference fit. So by actually using the one-piece X-axis that I always wanted to try and design, what I found is by homing in on the tolerances of this here, I was able to get this to click in nicely into place, and that also would compress the bearing just enough. Just click the other one in, and just enough compress the bearing so I get that little bit of resistance on the bar itself, not too much, still got the smooth action, but as a result now I had absolutely no movement whatsoever in that in the X-axis. So that then became the logical choice for me on this type of bearing, especially when I added into the fact the new print head. Because what we're now able to do, I'll just take that bearing out of there, just slides out of there. If we can imagine that bearing is on the rod and we want to fit the print head into place. We just clip that through, slide that over. You can see there we got a nice action in terms of the smoothness of that travelling up and down. But if we did feel that over time the bearing was wearing, or we had a little bit too much rot or play in it, we've got a bolt now that we can start tightening up the bolt through, effectively clamping that bearing. And because this bearing is able to be collapsed slightly, we can take away any sort of tension or take away any sort of play, on that bearing in order to ensure that there's absolutely no movement at all on the print head. So that's the reasoning behind swapping the bearings. So we started with the standard LM8UU. I tried the Drylin bearing. The part number, like I say, on this one is RJ4JP0108, but by far found this bearing to offer the best solution in creating a smoother, more accurate print table. But there is a price to be paid. This bearing traditionally is 3 times more money than the LM8UU bearing. So that might seem quite expensive when you talk about 3 times. You can traditionally pick these type of bearings up for around about 20, 30, 40 pence in the UK, depending on the quantity that you're buying. These can cost as much as £1 each in the UK, and the same again depending on the quantity that you're purchasing. However, given that between I don't know, £5, £6, £7 for the steel bearings, or £12 to £15 for these type bearings, it's the extra cost is well worth it, given the extra performance that we get from the machine. It's an integral part. It's the motion. Any 3D printer relies on smooth motion, and that's exactly what these bearings are providing us, which is why this is now the bearing of choice. So RJM0108 Igus Drylin bearing. And to build the Printtable S Series, depending on what print head you're using, if you're using this print head, you'll need 11 in total. If you're printing the other type, the old type print head, which essentially is still there in case you want to start modifying and adding different tools, even looking at using it for a CNC type machine, you'll probably want 4 on there to give you the extra spread of the load. So essentially we're going to be selling them on our website shortly in packs of 12, and that's to assist people in wanting to build the print table. The pack of 12, if you're using this print head, you'll have 1 spare. If you're using the other print head, obviously you'll use all of them. That's 3 for the print head, or 4 depending on what version you're using, and then 4 for the one side of the x-axis, and then we've got that part here. It's the opposite side to that. That's what it is, and then for the opposite side of the x-axis. And that's it really. So I just wanted to give you some information as to why that type of bearing has been selected and what are the benefits pro rata to the costs. Hope you found it informative, and I hope you have fun building your very own print table, and thank you for watching.